Hey, we're back together again. Today we're asking the question, how can we take derivatives of inverse functions at a point without actually finding the inverse and taking the derivative of it? I'm going to show you how to do it, but first I want to show you, well, how you might feel in the process. Learning this concept might make you feel like you've been on a spinning roller coaster. All right, let's do this. A function y equals f of f that is 1 to 1 will pass the horizontal line test and therefore have a unique inverse function y equals f inverse of x. We often say that the inverse function undoes the original function f of x, meaning that f of g of x equals x and g of f of x equals x. This leads to the reflexive property of inverse functions. The graph of f contains the point AB if and only if the graph of f inverse contains the point BA. This is going to be important very soon. The derivative of an inverse function. Let f be a function that's differentiable on an interval I if f has an inverse function g, then g is differentiable and therefore continuous on any x for which f prime of g of x does not equal 0. And g prime of x equals 1 over f prime of g of x. Or you could think of it like this: f inverse prime equals 1 over f prime of f inverse. Is your head spinning yet? We're going to focus on this one. I'm going to break it down for you, then show you how to use it, okay? First, we're going to derive that formula for the derivative of an inverse using the chain rule. So let g of x be the inverse of f of x. Therefore, we know that f of g of x equals x. That's the definition of an inverse function right there. Now, by the chain rule, we can take the derivative of both sides. And if you take the derivative of the left, you're going to take the derivative of the outside function, keeping the inside the same, times the derivative of the inside function. And then on the other side, the derivative of x is 1. Now I'm looking for g prime of x, so I'll just divide both sides by f prime of g of x. So here's where we're going to live for the next few minutes. Given that f of x equals 4x minus 3 and f prime of 2 equals 4, find the value of the derivative of f inverse of 5. I'm sorry, but these just make my head go in circles. Okay, we want the slope of the inverse at 5. That's what we're trying to figure out, the slope of the inverse at 5. Now, if 5 is the x value of our inverse, then that is the y value for the original function. So we're going to start with that. 5 equals 4x minus 3. And with that, I can solve for x to get a point on my function. So 4x equals 8 and x equals 2. So let's just keep track of what we know so far. Look down in the bottom right. We have a function, and we know a point on the function is 2, 5. We just discovered that. We have an inverse, and if we have 2, 5 on the original function, then on the inverse, we're going to have the point 5, 2. We also know from the problem itself that f prime of 2 equals 4. So at this point, 2, 5, we know that the slope is 4. So there's a picture of where we are. Now the equation we derived was this one. G prime of x equals 1 over f prime of g of x. And this is what we're looking for, the slope of the inverse function at the point 5, 2, which means we're looking for g prime of 5, which is 1 over f prime of g of 5. Well, what's g of 5? G of 5 is 2. So we're looking for 1 over f prime of 2. That's the slope of the original function at 2, which they told us, which we know is 4. So the slope of my inverse function at the point 5, 2 is 1/4. And notice 4, 1/4, those are just reciprocals of each other. That's a little bit of a shortcut for us to take note of. Let me give you some steps to finding the derivative of an inverse function. Number 1, set f of x equal to y to find x. In other words, find the inverse point. Then find the derivative of the original function. Evaluate the derivative. In other words, find the slope of that point in the main function. And then take the reciprocal of the slope. Let's see what it looks like in the form of a table, because it might clarify something. Find g prime of -1 if g of x is the inverse of f of x. So we need to find the slope of the inverse at -1. Well, that -1 is the y value for f of x. So that's here. Which means on our function, we're sitting at the point 3, -1. So let's sum up what we know. On our function, we're sitting at the point 3, -1, which means on our inverse function, we're sitting at the point -1, 3. And if the slope of f of x is -4, then the slope of g of x at its inverse point is -1/4. Let g be the inverse of f. Calculate g prime of -9 for f of x equals 4x cubed plus 5x. So we want the slope of the inverse at -9. Now remember, that -9 is the y value for f of x. So that's where we start. -9 equals 4x to the third plus 5x. Now, if you don't have a calculator, could you just look at this problem and solve it on your own? -9 is what we have to get at. We have 4 and 5, so what does x have to be? X has to be -1. Let's sum up what we know. On our function, we have the point -1, -9. So on its inverse, we have the point -9, -1. Now we need to find the slope of our function at that point. So we'll take the derivative, 12x squared plus 5, and we'll evaluate that at x equals -1, and we get 17. Therefore, the slope of the inverse function at its point is 1 over 17. One more, and this is a calculator question, and I really want you to have your calculator with you because I'm going to show you a lot of calculator tricks as we go through this. So if you have a TI-84, that's what I'm going to be using. If f of x equals 4x to the 7th minus x squared plus x minus 5, find the slope of the inverse at 3. Once again, that 3 is the y value for f of x, so that's where we start. This is why it's a calculator question, because this would be very difficult, at least bulky, to solve without a calculator. So here's what we're going to do. We're going to take that 3 and subtract it from both sides to get an equation that equals 0. Then grab your calculator and pop that in to the equation editor. Now I had -5, -3 in there instead of -8, but it's the same thing. Now pause the video as I go so you can use your calculator. Then you're going to graph it. Then you're going to hit the button second and trace to get calculate on top. We want to calculate the 0 of the function because we set our equation equal to 0. So hit enter on that, and then it'll ask you for a left bound. So you put the cursor just to the left of, or maybe below in this case, the x-axis. And then you hit enter, and it'll ask you for a right bound. So put the cursor on the other side of the x-axis and hit enter. And then it'll say, do you want me to guess? And you say yes by hitting enter once again. And here we have the 0 of the function x equals 1.1063959. That's a long decimal, but don't round until the end of the problem because you'll have the most accuracy if you keep a long decimal. Okay, so where are we? On our function, we have the point 1.106 blah, 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 comma 3. And then on our inverse function, we have 3 comma 1.106 blah, 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 blah. Now we need to find the slope of the original function. So we take the derivative, 28x to the 6th minus 2x plus 1. And then we need to evaluate that derivative at 1.1063959. Now again, you don't want to do that longhand. So grab your calculator again, go back to the equation editor and stick the derivative into the y2 line. Then get back to the main screen. Okay, then you hit alpha trace, and that'll bring up this menu of equations for you to choose from. Your derivative is in y2, so hit enter, and then tell it to evaluate y2 at 1.1063955 and hit enter. So now we have a slope of 50.14652918 for our original function. If we want the slope of the inverse function, we just put that over 1. And in your calculator, that gives you a slope of 0.019941446. And now, if you would like to shorten that up a bit, but make sure you leave me at least 3 decimal places. So that's it. Is your mind spinning? Because my mind is spinning. But practice again, practice, practice, practice. And once you get the hang of it, it's actually not that bad. Thank you for hanging in there with me. See you next time.